Copper dissolves in water to form the copper hexa-aqua 2 ion. So the things that we need to do for this question, we've got to draw the structure, state the shape, the coordination number, the oxidation state of central metal ion, and the bond angle. If you want to pause the video now so that you can have a go at it yourself, then do so. Okay, so I'm now going to answer the question. So I'll start off with copper in the middle, and I know that copper's got a 2+ charge because of the 2. If it's hexa, that means there's 6 aqua waters. So we're going to have 6 bonds around the copper, which means that it's going to be octahedral. And each one of these is going to be a water ligand. Okay, so that's the shape that I should be drawing. The shape is octahedral. Around that central copper atom there are 6 coordinate bonds. So the coordination number is 6. We've got the 2 up here, which means the oxidation state of central metal atom is +2, which also means really I should have square brackets around here and a 2+ charge, because copper's +2 and water is neutral. And the bond angle, well, it's an octahedral complex, the bond angle will be 90 degrees. Cobalt forms the complex cobalt tetrachloride. Things we have to do in this question, we've got to draw the shape of the complex, state the name of the shape, state the bond angle, state the coordination number, and then work out the charge on the complex. If you want to pause the video whilst you have a go at this yourself, do so now. Okay, so for the answer, I'm going to start with cobalt in the middle. Okay, there are 4 chloride ligands around it. So as the question doesn't tell me otherwise, I'm going to assume that it's tetrahedral. Okay, so answer to this one will be tetrahedral. State the name of the shape, there. Bond angle, if it's tetrahedral, the bond angle is going to be 109.5 degrees. Coordination number, look at the central cobalt, it's got 1, 2, 3, 4 coordinate bonds. The oxidation state of the central metal ion is +2, so let's just put that up there. Okay, so if you know that this is +2, each chloride is -1, and there are 4 of them. Cobalt is 2+, so overall the charge will be -2. I'm going to put square brackets around it, give it a -2 charge. Cobalt hexaamine 2 is a complex that can be formed when ammonia is added to aqueous cobalt 2+ ions. So the things I want you to do for this question, draw the complex present in the original solution, draw the resulting complex after the addition of excess ammonia. For each of the complexes I want the shape, the bond angle, the coordination number, the charge on the complex, and then as a bonus question, what type of reaction is described. You might not yet have covered that, so don't worry if you don't know. If you want to pause the video now and have a go, then do so. Okay, so the answer. In the original solution I had cobalt 2+ ions. It was an aqueous solution, so this is going to be surrounded by water ligands, and by now you should know that that will be an octahedral complex. So I'm going to draw my cobalt hexa-aqua ion. might as well do the charge whilst I'm here. So I know that this is 2 plus. I know that water is neutral, so I'm going to put my square brackets around it and give it a 2 plus charge. The shape is octahedral. And the bond angle will therefore be 90. Coordination number is 6. Okay, after I've added ammonia to it, so I'm going to form cobalt hexa, so 6 amine. Amine is of course ammonia. So 6 ammonia ligands. So I'm going to start again. Cobalt, if it's 6 coordinate, will be octahedral. And it's got 6 ammonia ligands. So I'm just going to add them around it like this. So octahedral, bond angle 90 degrees, coordination number 6. Again, cobalt's 2 plus. We can see that from up here where there's a 2 in Roman numerals. Ammonia itself is a neutral ligand, so the overall charge on the complex is still going to be 2 plus. Type of reaction, this is a ligand substitution. Okay, if you've not covered this yet, this basically means that we are swapping one type of ligand for a different type of ligand, so we're just substituting one thing for another. Copper 2 plus ions in solution form a complex with a blue colour. Draw the structure of this complex. If you want to pause the video whilst you do that, do it now. Okay, so I'm going to start off with a pen. Copper. By now you should know that copper forms an octahedral complex with 6 water ligands. Around it. And the colour of copper 2 plus ions in solution is blue, so you should know that one as well. And you should be thinking about putting the charge on this ion, so you know that water is a neutral ligand, copper is in a plus 2 state, so the charge on the whole ion is going to be 2 plus. Okay, for this one, if we come to the end of the question, and it says for each state, shape, bond angle and coordination number. So, shape is octahedral, bond angle 90 degrees, coordination number 6. Then we're going to come back up to the question. When hydrochloric acid is added to this solution, the colour changes to yellow as copper forms a new complex with chloride ions, CuCl4 2 minus. So, for this one, if you want to pause the video now and have a go at it. And for this one, I'm going to start off with copper in the middle. Because it doesn't tell me the shape, but I can see that it's 4 coordinate because there's 4 chlorines, I'm going to assume that it's tetrahedral. Okay. The question at the top tells me that it's got a 2 minus charge on it, which makes sense because if copper's 2 plus and there are 4 minuses surrounding it, it's going to have an overall 2 minus charge. The coordination number is 4. It's tetrahedral. And the bond angle then is going to be 109.5 degrees. Draw the shape of a nickel complex containing 6 fluoride ligands. What is the shape and bond angle? If the nickel is in a plus 2 oxidation state, what is the charge on the complex? If you want to pause the video whilst you try this question, do so now. Okay, so I'm going to start off with nickel, centre of my complex. It's got 6 ligands, therefore it's going to be octahedral. copper forms a square planar complex with the formula CuNH3 2+. Draw the shape of this complex, labelling the bond angle and coordination number. If you want to have a go yourself, pause the video now. Okay, I'm going to start by answering this question and talking about the fact that it's telling me that it's square planar. Remember, anything that's 4 coordinate, if the question doesn't tell you otherwise, you assume that it's going to be tetrahedral. But in this question, we know that it's square planar. I'm going to start off with the copper in the middle. I'm going to draw a square planar complex with 4 ammonia ligands. You would be well within your rights to draw it like this. But it's more common to use your dashes and wedges bonds to show that you understand that it's in 3D. The formula at the top says it's got a 2+ charge, so I'm going to add my brackets and a charge. Then it says draw the shape, which is square planar, as the question said. Bond angle is 90 degrees, and the coordination number is 4.